Hi everybody, welcome back. In this video we're going to talk about information from section 7.3 of AP Calculus, sketching slope fields. And we've been talking about differential equations, and eventually in this unit we're going to talk about finding antiderivatives of a specific kind, but we have already looked at how to find antiderivatives of some differential equations in the last unit, back in Unit 6. But there are times where we can't find the antiderivative of a function, or we don't know how to do that yet, where it might be beneficial for us to use what's known as a slope field to help us analyze a particular differential equation. So, what is a slope field? Well, it's a field of slope. I've said this for so many years. What is a slope field? It's a field of slopes. Basically, for those of you who've done, some physics, it looks like a magnetic field diagram or, something like that. Where basically what we're doing is we're finding the slope using the differential equation at a variety of points, and we're sketching all of those. And then we get a picture of what, in general, all of the antiderivatives look like. So let's take a look at how, and this is one of those things that, doing it is actually pretty simple, as long as you know what's going on. So we're sketching a slope field. We're given the differential equation dy dx equals x minus 2y. And we're given a bunch of indicated points on our graph here. And at these points that are indicated, what we're going to do is we are going to place a little hash mark representing the slope, which we're going to get from this differential equation. So I'm going to pick one of the points in this diagram. Let's start with 1, 1. Okay? And I'm going to substitute the coordinates to that point into dy dx. So I'm going to put 1 in here for x, 1 in here for y. And when I do that, I get 1 minus 2. I get negative 1 for the value of dy dx at this point, 1, 1. And since the value of dy dx at 1, 1 is negative 1, I'm going to go ahead and draw a little hash mark with a slope of negative 1 at that point. And then I'm going to go ahead and I'm going to go to another point. Let's go over here to 2, 1. And so I put 2 in for x and 1 in for y, and I calculate and find that dy dx is 0. Okay, and I pick another point. Let's say I pick over here where x is 2 and y is 0. The slope is 2. Now, one of the things, as you sketch more and more of these, you'll realize that you can do it a whole lot quicker if you can identify and find some patterns in the slope field. So as I'm plotting slope lines, I'm going to be on the lookout for a pattern that's going to help me generate these slope lines more easily. This differential equation contains both x and y, which means that the patterns that exist in this slope field are dependent on both the values of x and the value of y. So any pattern that we see in this slope field is going to be kind of on a diagonal basis. If this differential equation only contained an expression of x, then what we would see is we would see that the x value exclusively controls what's going on with the slope lines. So we would see vertical patterns, like every one of the dots in this vertical pattern would have the same slope if this were a differential equation strictly in terms of x. If it were a differential equation strictly in terms of y, we would have horizontal patterns because the slope would be strictly dependent on the value of y. In this case, since we have both x and y, we're going to have diagonal kinds of patterns, and hopefully we'll find one of those eventually. All right, next point I've got here, I've got the point 1, 0. X is 1, y is 0. That's a slope of 1. Okay, let's see. 0, 0, put 0 in for x, 0 in for y, I get 0 as my slope. And now we found our first idea of a pattern. It looks like on this diagonal, kind of the line y equals 1/2 x, we end up with the same slope pattern. And we can verify that over here if we go over to this point, -2, -1. If we put -2 in here for x and -1 in for y, and we calculate dy dx, we again get 0. So we've seen our pattern. I'm going to feel pretty good about this. Let's do one more verification. Let's check it at this point right here. If I put -1, 0 in there, I get a slope of -1, which is exactly what the slope is over here. So once I've calculated a slope in this slope field, I can go along the line. I can go up 1 and over 2, or over 2 to the left and down 1 from that particular slope line and place in a slope with the identical value. So like right here, the slope could be 1. Right here, the slope would be 2. Is there anything else that I've got calculated yet? Not yet. So I can find the value here. At 0, 1, the slope is -2. 0 minus 2 is -2. So I can put in a slope line of -2, and that'll be the same slope line at this point, and the same slope line at this point. And let's see. Now I just need to pick points that I don't have the slope at yet. Let's go to the point 1, 2. 1 minus 2 times 2, that's -3. So we're going to put a slope of -3. And there will be a slope of -3 at this point as well. By the way, as the slopes get steeper, it gets harder and harder to tell, exactly the difference between a slope of -3 and a slope of -4 or -5. Just make sure that the slopes are tending to look steeper. Like right here, the slope is -5. It should look a little steeper than at -4, but it's really hard to tell once you get really steep or really flat. It's kind of easy to tell between like -2 and 2 what the slope lines are, but outside of those it gets a little bit more difficult. The slope here was 2, so the slope here is 2. And let's see, at 1, -1, when x is 1 and y is -1, the slope is 3. So the slope will also be 3 down here. At 2, -1, the slope is 4. So the slope will be 4 here as well. Here it's 5. And over here it's 6. So notice how hard it is to tell the difference between 5 and 6. All right, so there's a sketch of our slope field. Now remember this pattern that we had where, as we went up 1 and over 2 from one point to the next, we maintained the slope, because that's going to come into play in what I'm about to do next. One of the things that we can do once we have a slope field is that we can sketch a particular solution curve that passes through a given point on the graph. And we can do that by using the slope lines that are present. Excuse me, my voice is a little scratchy. So let's go ahead and do part B here. We're going to sketch the particular solution curve that passes through the point where f of -1 is equal to 0. So when x is -1, y is equal to 0. So that point is right here on this graph. And you see the slope line here tells us that the curve is going to go off in this direction and in this direction from this point. Now, as I move to the left from that point, if you look at the slope diagram, as I move to the left, the slopes get steeper. As I move up, the slopes get steeper. So as I move to the left here, the slopes are going to continue to get steeper and steeper as we move off that end of the slope field for this particular solution. Now here's where it gets interesting. We've got a negative slope coming out of this point, but eventually we're going to hit this little line right here. Where the slope is 0. And when our solution hits that line, the slope of our solution curve should be 0. The other thing that's going to happen that's interesting in this problem is, we've got this pattern that goes throughout the entire slope field. Well, at some point this curve is going to hit where the slope is 1/2. And once you get on that line where the slope is 1/2, the solution curve can't get off of it because the slope just stays 1/2 all along that line. So what happens here is this gets kind of close, and right about here it hits the line where the slope is 1/2. And then from there, the slope field is just going to continue to go upward with a slope of 1/2. And there's our solution curve that passes through that point. Okay, and your solution curve when you sketch one of these should be fairly close. There's going to be a little bit of room for error and interpretation, but it should be fairly close. All right, the next one passes through the point where f of 2 is equal to -1. So that's this point right here. Not much slope field for me to draw here. As I move to the left, this is going to get steeper and steeper as I move down into the left. And to the right, it's going to just start to flatten out a little bit. And boom, I'm off the edge of my curve. And so there's all I can get for my particular solution curve for that slope field. All right, we're going to call it quits there for this video. We're going to come back in a second video, and we're going to look at a couple of old AP free response parts that include sketching slope fields and particular solutions, and some other stuff that we've learned along the way thus far this year in calculus. Okay, so we'll see you next time for video 2 on this topic. Enjoy the rest of your day, and we'll see you then. Bye-bye.